Let's first go ahead and check your warm-up. And what we had was -5 minus -7.5, which is the same as plus positive 7.5. So 7.5 wins the sign game. It's positive. 1.5 taken away from 7.5 is 6.0. Okay. 5 times 5 is 25, and that would have been 10 to the negative. I'll write it here. 25 times 10 to the negative 10. But that is not the final answer, because this is not in nice scientific notation. So we actually have to, 25 is the same as 2.5 times 10 to the 1, right? And then we do that times 10 to the negative 10. So what happens is we have a positive 1 and a negative 10. So we get 2.5 times 10 to the negative 9. Okay, I know these irritate a few of you, maybe most of you. Okay, so this one now I add 20 to both sides. 120 divided by 5. Well, 5 goes into 100 20 times. So, and 24 times, so 24 is what I get for W. Convert 20 degrees to Fahrenheit, so 20 divided by 5 is 4. 4 times 9 is 36. 36 minus 32 is, or 36, sorry, this was all negative, right? So negative 20 divided by 5 is negative 4. Negative 4 times 9 is negative 36. Negative 36 and a positive 32 is a negative 4 degrees Fahrenheit. All right, 20 times 3 is 60. And then 3/4 of 20 would be 15, so 60 plus 15, 75. A third less, I just say a third instead of 33.33%, less than 24. Well, a third of 24 is 8. Take 8 away from 24 and we get $16. Okay, now we're going to jump into this concept called estimating square roots, okay? Now, it's always good to practice writing out the perfect squares, so I want you to write the perfect squares up through 81, okay? So 1, because 1 times 1 is 1, 4, which is 2 times 2, 9, which is 3 times 3, 16, 25. If you could get good at writing these without having to say in your head, oh, okay, 6 times 6, 7 times 7, or that's the best way to do it. Okay, so those are the magic perfect squares. Knowing these will, for the rest of your life, will help a lot, okay? And it's just fun. So, now the square root of a perfect square is an integer. So like the square root of 25 is 5, because 5 squared equals 25. Square root of 36 equals 6, and these are all perfect integers. So if some of these have perfect integer answers, that's why they're called the perfect squares. Now, not everything's perfect, unfortunately. Like, the square root of 29. Now, what would that be? Okay, well, we see here it would be in there, right? So the square root of 25 is 5. The square root of 36 is 6. So we can guess that the square root of 29 would be somewhere between 5 and 6, a decimal number between 5 and 6. It's going to be 5 something. So what we could do is just write it on a number line. This would be the square root of 25, which is 5, and this would be the square root of 36, which happens to be the number 6. And 29 is probably a little closer to here. So this would be the square root of 29. Does that make sense? On a number line between 5 and 6 somewhere. Okay, so you can guesstimate the square roots of things that are not perfect. Okay, and they were going to be asked, like it would have said, what are the two consecutive whole numbers that the square root of 9 falls between? And that would be between 5 and 6. Okay, so let's look at this one. Between which two consecutive whole numbers is the square root of 20? Now, there is no perfect square root of 20, but there are some numbers that we know, okay? let's look at what we do know. We know that 13 squared equals 169, right? And 14 squared equals 196. And 15 squared equals 225. Now at some point, so the square root of 196, and so 200 is between 196 and 225, isn't it? It's quite close to 196. So the two whole numbers that the square root of 200 would fall between would be 14 and 15. Okay, now draw a number line. This is where I'm going to use a calculator to show you some stuff. Now I'm going to use my scientific calculator because it's the one that has the square root symbol. Okay, now if your parent has an iPhone, you can find this in their utilities and turn it sideways, and now we have a scientific calculator. I'm trying to get the glare off there. And there is a square root sign, and it would be this one right here. Okay, it has a little 2 and an X. So if I wanted to find the square root of 25, I type in 25. See if we can see this without a glare. Let me try and focus it better. And later this year, which we're getting close to, we're going to be using a calculator using the Pythagorean theorem on a worksheet. So you're going to need to have access to a calculator that does this. Okay, so let's try. We said between 4 and 5 was the square root of 29. So I'm going to write 29, push the square root symbol, and look, we get 5.38, and that is what we got, right, between 5 and 6. So let's check the square root of 200, which we just did, and that would be 14.14. So we were close, between 14 and 15. Okay, now they always go out, each calculator goes out a certain number of digits, but I want you to know if this calculator was bigger, these numbers would keep going. They go on and on forever, no matter what. As long as it's not a perfect square, these numbers are forever, indefinite. So I just did the square root of 21. Now, the only time that won't happen is if you do a perfect square. All the others go on and on and on and on forever, okay? And these are actually called irrational numbers. A square root of a non-perfect number is not rational. It means you cannot make it into a fraction, okay? So, and I think I've talked about that at least once in class, is that they are irrational. So this is an irrational number, it goes on and on forever. Remember, irrational. This actually is rational because this can be written 2 1/3, right? And this one is already written as a fraction, so we know that that is a rational number. Okay, so these two are irrational, and these two are rational. It's good to know which ones are rational and which ones are not. Okay, now we're going to draw a number line and show the approximate location of the points. So we've got these numbers, and we got to figure out where they are located. Now, not everybody is greater than 0, so let's have 0 be here, 1 be here, because we want to make sure everybody's represented. That's a -1. Now, I think I've got it down. Okay, so pi we know is about 3.14. So we're going to put that right here and put pi. Okay, and square root of 2. Now you're like, I don't have a calculator. What is the square root of 2? Well, the square root of 2 is going to be between the square root of 1 and the square root of 4, right? Square root of 1 is 1. Square root of 4 is 2. So the square root of 2 is somewhere in between here, isn't it? And it's going to be, just go ahead and do a dot, and we're going to say square root of 2. Okay. Now 2.33333 is the same as 2 1/3, so I'm going to go about a third past 2 and write my 2.3 with the repetand over it. And then negative 1/2 is a nice one. It's right here. Okay, so if you were to write them in order from least to greatest, you negative 1/2, square root of 2, 2.3 with a bar, and pi. That's the order from least to greatest. Now it says describe each number as rational or irrational. I think I already did that. So we could say irrational is pi and square root of 2. Okay, rational numbers were negative 1/2 and 2.3 with the bar. A lot of people think this one is not rational, but it actually can be written as a fraction, and that's the true test. Okay, now we are going to do practice. So you can go ahead and shut me off. And okay, now we're going to find the square roots between two consecutive whole numbers here. So the square root of 7 is between what two whole numbers? Okay, well, I'm going to think of the perfect squares that I do know. Below 7 would be square root of 4, and above 7 would be square root of 9, right? So that would be between 2 and 3. Okay, square root of 70. Well, I'm thinking the perfect square that I know of would be square root of 64 and square root of 81, which would be between 8 and 9, between 64 and 81. 700, now that's a tricky one, right? So I might need to do some guessing. Like, I know that 20 squared is 400, so that's not going to do it. I know that 30 squared is 900. Okay, so I might just want to write that 30 squared equals 900. 25 squared is actually 625. Okay, so I feel like I'm getting closer. That's probably going to be one of them. So I might need to go 26 squared and see what that is. And I know we did this in the last lesson. It's irritating. We could have grabbed it out. So we get 676. Oh dear. So I thought we were closer to being done than that. Oops. 26 squared equals 676. So that means I probably need to get 27 squared. I'm going to do this on Scratch, right? Now I bet some of you wish you had your calculators. I do right now. I'm tempted to grab it. Okay, good. We get 729 for 27 squared. Okay, so we now have found the two numbers that it's between, 26 and 27. Okay, now this one is a lot like what we did the other day, I think. So what we're going to do is, this is, remember, one, if we were to draw boxes, this would be 1 squared and 1 squared. Okay, or 1 and 1. So 1 plus 1 equals x squared, right? So 1 plus 1 equals x squared. So 2 equals x squared. So something times itself equals 2. So how we do that is we just write x equals the square root of 2. And we leave it like that. Okay? And this one, we have 1 squared, or 1, plus y squared equals 2 squared, which is 4, right? So 1 plus y squared equals 4. Okay, now that means we subtract 1 from both sides. We get y squared equals 3. So y equals the square root of 3. And we're going to leave it like that. Okay, draw a number line, and we're going to show these, and then figure out which one of them are irrational. Okay, I see we've got in the negatives, but not by much. So I'm going to -1. Okay, I'm going to do the 2 easy ones. 3 easy ones first, maybe. Okay, -1/3 is right here. Pi is 3.14, so that's about here. And then 3.3 with the bar, okay, is 1/3, right? So we're going to put that right here. And now the last one is square root of 3. Well, the square root of 3 is going to be between the square root of 1 and the square root of 4, right? And the square root of 1 is 1 and the square root of 4 is 2. So it's going to be about here, closer to the square root of 4 than the square root of 1. So there I put that. Now which one of these are irrational? I'm just going to write irrational, and that would be square root of 3 and pi. And there you have it. We are done with that lesson.